Hi everyone, in this demo we are going to see how we can federate secrets across clusters using SPIKE. To learn more about SPIKE and SPIKE's components, and also the identity control plane that SPIKE relies on, which is SPIFFE, you can go to spike.ist, which is SPIKE's website. And also to learn more about SPIFFE, you can go and navigate spiffe.io. You can click this documentation link down here, and you can learn about SPIFFE and SPIRE and the architecture concepts behind SPIRE. And similarly, if you go to SPIKE and you go getting started and you dive into, let's see, if you dive into SPIKE architecture and then go to system overview, you can learn like a deeper information about SPIKE and how it is architected. I'm not going to delve deeper into those concepts in this demo. I'll just show how we can do end-to-end secrets federation. Let me briefly talk about the setup that I am going to show. So I have 5 clusters in our setup. I have one management cluster and a workload cluster, and also 3 what I call edge clusters. And in those edge clusters we have SPIKE keeper instances. And let's start with Nexus, I guess. In the management cluster we have SPIKE Nexus, and SPIKE Nexus is for all practical purposes is our secret store. It stores secrets, keys, sensitive materials securely, and it dispatches to the workloads that need those secrets based on secure MTLS SPIFFE federation relationship. And we have SPIKE Pilot down here. SPIKE Pilot is like a bastion host. You can talk to SPIKE Nexus and manage it, create policies for workloads. For like day one administrative operations, you can use SPIKE Pilot. Other than that, these keepers are they store shards of the root key of SPIKE Nexus. What we do is SPIKE Nexus has a root key in memory, which is used to encrypt secrets, and that root key is never persisted to disk for security reasons. It's always in memory. So if we don't have these edge clusters and SPIKE keepers, when we refresh SPIKE Nexus, the root key will be gone, a new root key will be generated, and the persisted secrets, which are encrypted, will be like garbage because you won't be able to decrypt them. So what Nexus does is it shards that root key by using Shamir's secret sharing scheme and splits it into partitions. In our demo setup, the partition is 9 shards and 4 with a threshold of 4, which means you need to have 4 shards that the keepers keep to regenerate the entire root key. So you don't need to have the all of the 9 shards in total. Just 4 of the shards is adequate. Why number 4 but not number 2, number 3? Because in this particular setup, if you realize, we have 3 keepers per edge cluster. So if in the unlikely event that one of the edge clusters is exposed and somebody dives into it and tries to like get the shards, which is really hard because the shards are also in the memory of the keeper instances. So you need to like attach a debugger, elevate yourself to system admin, and try to inspect the memory of the keeper. But assume that all of those have happened. Somebody infiltrated to say edge cluster 1 and extracted like 3 shards from 3 separate keepers. Still, it's not enough to regenerate root key because we need 4 shards. So the attacker will have to attack to one of the other clusters to get the extra shard as well. So that gives a level of security. And before I continue, this setup might be seen as an overkill because just to keep, like, keepers are simple. They simply keep a single data, which is the shard, and they do nothing else. It's just a tiny little bag, essentially. And just to maintain those bags, maintaining a separate cluster can be an overkill, but typically, like if you are managing a fleet that you have like tens, hundreds, even thousands of clusters lying around, so you can selectively distribute some of your keepers to those clusters. This relationship is based on that idea, and to show the capabilities of how you can freely distribute components of Spike around thanks to SPIFFE, because like since we are using SPIFFE and SPIRE to establish the identity control plane, the network boundaries don't matter that much. You can move any of the components that you see here to any of the places that you see on this topology, as long as there is network visibility. From the perspective of SPIFFE, it doesn't care, because network is just an extra detail for it. So that's that one. If I didn't have that much clusters, what I would have done would be to like put the keepers along with Nexus and Pilot to the management cluster, and then like define taints and tolerations so that each keeper is stuck to a different node. So I don't have clusters of like bundles of keepers on the same machine. They are evenly distributed. So that would give some level of redundancy. Like if a node like crashes, we'll have a quorum of keepers that can maintain and reconstruct the root key back again. That's one thing, and this is like a federation, like logical topology. From the network connectivity perspective, our structure looks like this. We have an operator that manages secrets, defines policies on the secrets using Spike Pilot, and Spike Pilot then uses an API to talk to Spike Nexus. We have a SQLite backing store that stores the encrypted secrets, which Spike Nexus Spike Nexus uses. And all of the connections that you see here, like this API connectivity, the shard exchange, the fetching and setting secrets, all of them are secured by SPIFFE MTLS. So these are secure MTLS connections that cannot be eavesdropped, that cannot be tampered, which gives like a sense of security to the entire architecture as well. So let's go dive into the demo. So I have like 5 terminals here, and each terminal will be like one of those clusters. So I'll logically like segregate them so that like this will be like our management cluster, this will be our workload cluster, and these will be like edge cluster 1, edge cluster 2, and edge cluster 3. And all of these clusters, since we are using SPIRE, they have their own trust domains to identify their trust boundaries. So for management cluster, it is mgmt.spike.ist, and these trust domains don't have to look like a DNS entity, and they are not technical DNSs. They don't resolve. Nobody resolves them. So instead of like management spike, you can just say management -spike, for example. But like from like production experience, I can say that like constructing your trust boundaries like a domain gives you some sense of structure, because like most of the entities that you assign privileges to look some sort of, domain structure. Like take Active Directory, for example. You have organizational units and other Active Directory entities that resemble a domain structure. So making this look like a domain name makes it easier to reason about, I can say. So for the workload, the trust domain is workload.spike.ist, and edge clusters go by the name of edge1 spike.ist, edge2 spike.ist, edge3 spike.ist. And in these clusters, like I've shown in the former diagram, we are going to deploy certain entities. So all of those clusters will have SPIRE installed on them to establish that federation, identity control plane, and all the other good things. Another SPIRE here, another SPIRE there. And we'll have Spike components. So we'll have Spike Pilot, which is our management tool, and Spike Nexus, which is our secret store. And here we'll have Spike Keepers, 3 of them, and here as well 3 Spike Keepers, and here 3 more Spike Keepers. Let's see what else. And in this workload cluster, we'll have a demo application that would be able to fetch and retrieve secrets. So let me kind of draw borders around them so that they look like components. Spike Nexus, Spike Pilot. What else do we have? We have keepers here, keepers there, and keepers here. Yeah, those are the critical components. So I can show overall network flow. So we have a happy user here. I'll try to do my best to draw a user with my terrible artistic skills. So the user will this is the administrator, where it will talk to Spike Pilot to register policies to Spike Nexus so that this demo application can create or delete or retrieve secrets from Spike Nexus based on the policies that we assign them. And Spike Nexus will be sending, and if it crashes, fetching Shamir shards of the root key to these 3 keeper instances. So essentially we have a federation relationship which looks like a hub and spoke topology. So we have a hub here, which is the management hub, and it kind of creates federation relationships between all of these spokes. So workload, edge 1, edge 2, and edge 3 would need to talk to the management cluster, but there is no cross chatter. These edge clusters don't and should not have to talk to each other. Similarly, the workload doesn't know or care about any of the edge clusters. It's just a like I said, it's just a hub and spoke topology. So that's that one. Let me shell into all of these clusters and see how it goes from there. So what I'll do, I have make files that kind of ease these operations. So what I'm going to do is first I'll clean up the Docker so that I'll have I'll have enough space to create these images. Since these are virtual machines, I don't have too much real estate, so I'm keeping things frugal. And after that, I'll reset the Minikube cluster so that if we have any remnant from former demos, I will get rid of it and start with a blank clean slate. Then I'll start the Minikube cluster, and let me show you the start script to show what features that I enable in that Minikube start. So it's like a regular Minikube with two additional add-ons. One of them is registry and the other is CSI hostpath driver. The hostpath driver is to mimic persistent volumes, and registry is to use as a local registry so that I can deploy stuff. Like we could have used a separate external shared registry, but I thought, keeping the images closer to the cluster may speed things up a little. So I am using a local Minikube registry in each of those clusters. So after I start the cluster, I'll build images, I'll push images, and then I'll go to the federation setup. So for each cluster, I'll deploy relevant parts of the demo. So for management cluster, it will be Nexus and Pilot. For the edge clusters, it will be the Keeper instances along with SPIRE. We'll deploy SPIRE to all of those clusters, and the Docker files are here. You can check them out. They are relatively easy to follow. All of them have a single entry point, and all of those entry points are defined in this app folder. And this project, if you are curious, you can navigate to github.com SPIFFE SPIKE, and while you are at there, you see there's this star thing. It gives us visibility. So if you want and if you like this project and if you think it will make other people's life better and if it will make DevOps sleep more, then just give us a star. It will help us promote this thing, and it will help the community. So that said, this is the project, github.com SPIFFE SPIKE, and it has a README, documentation, and all of the nice things that you can see. If you want to contribute, there's contribution guidelines, and overall that's it. Just dive into the code, look around. If you have any feedback, give us feedback. Let me go back to my make files. So after that, I need to establish a federation relationship, and for that federation relationship, we need to do two things. There are several ways to establish federation between SPIRE servers, but typically most of the time it requires a out-of-band trust bundle exchange. There is a way to export trust bundles from SPIRE servers, and there is a way to import them into SPIRE servers. And after this initial exchange, if the SPIRE server exposes a bundle endpoint, then they can automatically continue further trust bundle exchanges without having to manually establish the trust relationship. It will the clusters will continue trusting each other forever, essentially. So what we'll do is we'll expose the bundle endpoints in all of those clusters. And since this is a demo setup, I don't have DNS, I don't have a load balancer and anything like that. So what I'm going to do is I'll just port forward necessary things and define the proper ports and proper configurations to let things see each other. And all of those configurations are defined in this config Helm structure. So this is the configuration for edge cluster, for example. This is the configuration for management cluster. You can check them out in your spare time. So after I port forward, I'll extract bundles from all the clusters. Then I'll exchange bundles by doing demo bundle extract and demo bundle set, which will make all of the clusters attain the trust material to trust one another, and it will establish the hub spoke topology that I have talked about a while ago. And then I need to port forward a bunch of stuff as well, because the keepers and Nexus need to talk to each other. So I need to port forward Nexus service to expose it to the keepers, and I need to port forward keepers to expose them to Nexus, essentially. And after I do all those port forwarding, I'll deploy a demo application. And this demo application is it has just a couple of lines of code. It's utilizing the SPIKE Go SDK, and then it's creating a secret and putting it to the Nexus in the management cluster. So like it's putting a secret to in a cluster that is not its current cluster by using a secure MTLS connection that is provided by SPIFFE. So that's that one. It creates a secret, and then it reads the secrets back, and then prints it to the console. That's the demo application. We'll deploy it, and then we'll run it. So let's start, shall we? So first I'll go to SPIKE folder in all of these clusters. Enter. Okay, so I'll follow these make files in order. So first I'll do Docker cleanup in all of them. Make Docker cleanup. I'll copy and paste to all of these. Copy, paste, 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 paste. Let's reset Docker everywhere. Then I'll clear these terminals again. Then I'll do make Kate's delete. Yeah. So I'll delete the Minikube clusters by resetting Docker, like by pruning Docker. Those Minikubes should have been gone already, but like just in case, better to be safe than sorry. I'll reset them, and then I'll start Minikube in all of these. Make Kate's start. So let me copy. Oh, come on. Make Kate's start. I'll copy and paste it to all the other clusters again. Paste, paste, paste. Enter, 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 enter. This will take a while. I'll enjoy my tea in the meantime. Okay, so we have our clusters set up. Now I'm going to build our container images by doing make Docker build in all of these clusters. Let's do them one by one. Make Docker build, and I'll copy and paste this to other clusters as well. This one, this one, this one, and that one. This will take a little while. I'll probably fast forward it as well. Alright, all of our images are built. Now I need to forward Docker registry so I can push those images to the internal registry of the Minikube cluster. But since I am going to do other stuff as well, I'll create tmux shells in all of these machines, so I can do tabbed items one at a time. Let me tmux, come on, tmux, and then I'll do make Docker forward registry in all of these clusters. Paste, paste, and paste. Enter, enter. It's okay, we are forwarding registry, but I need a second terminal, so I'll do command BC to create another tab in all of those tmux sessions. And after forwarding registry, I'm going to push those Docker images, make Docker push. So I'll do them in all of those clusters again in parallel. Let me paste those. Paste. Paste. Okay, that was fast. Let's see what else we are going to do. So the Kubernetes setup is done. We have images. Now we need to actually deploy the relevant demo applications, and that's done by make demo deploy in all of these clusters. So I'll do that. And that will deploy the necessary components. So it will deploy SPIRE to all of those clusters, and it will also deploy Spike Pilot, Spike Nexus to management cluster, Spike Keepers to the edge cluster, and so on. Let me run these in all of the clusters again. Okay, now I have those SPIRE and SPIKE deployed. Let's see what we have here. So kubectl get -n SPIRE server. I have SPIRE server running, also SPIRE OIDC discovery provider app, and on SPIRE system I have SPIFFE agent and like a CSI driver up and running. And if I go to a kubectl get -n Spike, we have Spike Pilot and Spike Nexus. Spike Nexus is not ready because we haven't established the connectivity between the Nexus and the Keepers, so it's still waiting to be able to get a quorum of Keepers to initiate itself. So to do that, we will first need to establish a federation relationship between these clusters, and for that I'll start by forwarding the bundle endpoint of the SPIRE server. Make demo SPIRE bundle port forward. This will port forward the bundle endpoint in SPIRE server. So I'll have to port forward the bundle endpoints in all of the clusters, because to establish the hub and spoke topology that I mentioned before, all of these clusters need to expose their bundle endpoints to one another. Then I'm going to manually exchange the trust bundles. So first I'll do make demo bundle extract, which will extract the trust bundle by asking the SPIRE server, and then I'll exchange those extracted trust bundles with the clusters that need them. So workspace, the management cluster will get the bundles from workload and edge clusters, and edge cluster will only get the bundle from management cluster, because it doesn't have to know about workload cluster, for example, or the other edge clusters. And that goes the same for the workload cluster as well. It will only get the workload cluster, will only ask the bundle from the management cluster. So I extracted the bundles. Then I'm going to do make demo bundle set, which will import the bundles that we exchanged into the SPIRE server, which will establish the hub and spoke trust relationship between the management cluster and those edge and workload clusters. So let me do those. So now things should be more or less set up. One last thing I need to do is to expose the edge endpoints and also the Spike Nexus service. so that the workload can talk to Nexus and the edges can exchange shards between the Nexus. So first I'll export Spike Nexus, make demo Spike Nexus port forward. This will expose a service that we have to the outside world, and I'll do make demo Spike keeper port forward in all of those keeper clusters, which will do a similar thing. It will expose the keeper endpoints essentially. Let me paste this. Let me paste this one as well. So if I now do kubectl getbo dash and spike, we can see that a Spike Nexus has initialized successfully because it was able to establish a relationship between these keeper instances. So if I do here again kubectl getbo dash and spike, I'll see that I have 3 keepers here up and running, and I can do the same in other clusters as well. Kubectl getbo dash and spike, I have 3 keepers here. Kubectl getbo dash and spike, I have 3 more keepers here. So far so good, and I think now we can deploy a demo application and try to get and set some secrets. So for this, I have another make command, make demo deploy workload. It will deploy a demo application. So if I go to the workload namespace, I can see that we have a app here, and I can do make demo exec, which will execute the main file that I showed you a while ago. Let me show it again. Just give me a second. So when I do make demo exec, it will run this code. Essentially, we'll establish a connection to Spike Nexus. We'll try to put a secret, and then we'll try to get the secret back and display it on the console. Let's see how that one goes. So when I enter, it will say error writing secret unauthorized. Why? Because although we can establish MTLS connectivity between Nexus and workload due to SPIFFE Federation, still we need to define a policy for the workload to be able to let it create secrets or read secrets or list secrets, things like that. So for this, I have, let me see. I have this workload set policies script. I can run it directly with a make file, but I want to run these one by one to show you the effect of like read and write. If you see the code, first we are trying to create a secret and then try to read it back. So if I allow the workload to create but not read, I'm expecting to get a separate error, a different error from the one that I got here. So let's define a write policy here. It says policy created successfully. So now if I execute the demo workload again, it will say error reading secret instead of writing secret. So we are able to write the secret, but we weren't able to read that secret. So let's see if we actually have the secret. So let's get kubectl getbo dash and spike. I have the SPIFFE Spike Nexus and SPIFFE Spike pilot here. So I can do kubectl exec, just give me a second, this pod dash and spike dash dash spike secret list, and it will say we have a secret name, tenants demo db creds. So if I say spike secret get tenants demo db creds, I can see that we have a secret with a password and a username. So our workload was able to set the secret, but it's not able to read it right now. To make it read, we'll define a read policy. And by the way, you can do this at a single step as well. You can say read comma write, and it will be a single operation. Just for the sake of demo, I am splitting it and to show you how different capabilities and roles affect workload execution. So let me paste this one. I am allowing the workload to read as well. And now when I run the command again, it can say, well, secret found, this is my secret, and it can use it in the application. And the cool thing is we didn't have to rotate the workload, redeploy it. It's dynamically fetching the secret. And it's securely getting the secret. All that secret is being transported through MTLS with perfect forward secrecy. So it's pretty much secure. So that's the end of the demo, I guess. You can, of course, extend this setup. Like I said, one idea would be to have a centralized Spike Nexus in the management cluster, but like local Spike Nexus instances in the workload cluster to replicate the secrets that are labeled for that cluster, so that each cluster can get its own destined secret and cannot see other clusters' secrets. Or you can create mechanisms to dynamically generate and rotate and distribute secrets without having to redeploy workloads. But as far as cross-cluster secrets federation with SPIFFE and SPIKE goes, that's all there is to it. So until next time, keep your secrets secret.